All right, here are solutions for quiz 7 from Math 1 and 12. And these first problems we're just asked to simplify, essentially, get rid of all the trig functions and inverse trig functions. So for this first one, I think the easiest way to do it is figure out what the sine of 7 pi over 6 is, because that's a point on your unit circle. If you draw your unit circle, pi is kind of over here, so 7 pi over 6 is a little bit more than pi, talking about this guy down here. And the y-coordinate right here is -1/2. So what this question is asking you to figure out is what is the arc sine of -1/2. Maybe I'll label this point as x-coordinate is -√3/2, and its y-coordinate is -1/2. This is 7 pi over 6. So the arc sine of -1/2 is asking you for the angle that is between -pi/2 and +pi/2, for which the sine of that angle is -1/2. So the point where that happens is kind of somewhere over here. And so what the question is asking you is, what is this angle here? Well, that angle there is -pi/6, if we want this y-coordinate to be -1/2. So the answer to this question is -pi/6. And maybe I'll put parenthetically, it's not 7 pi over 6, because range of arc sine is, or only includes, numbers from -pi/2 up to +pi/2. Had this value, 7 pi over 6, been in this range, then the answer would have just been this value. But since this value is not in this range, there's a little bit more work to do. All right, moving on. The second one. What about the cosine of the arc sine of root 7/4? Well, you could try to figure out what the arc sine of root 7/4 is. For what angle between -pi/2 and pi/2 is the sine of that angle equal to root 7/4. But I don't think you'll find anything on your unit circle that you have memorized for which that's true. So an easier way to do this problem, and really a method that we learned you can do anytime you have an inverse trig function nested inside of a trig function, is this little substitution. So what I'm going to do is recognize that arc sine of x, or arc sine, I guess, of root 7/4 is an angle. And because it's an angle, I'm going to give it a name. I'm going to name it t. T is a letter I often use for an angle, short for theta. So if I'm calling this thing t, then really the question is just asking me what is the cosine of t. How are you going to figure out the cosine of t? Well, I'm going to need to draw a triangle. How are you going to draw a triangle? By using this information. So I'll draw a right triangle, I'll arbitrarily throw t down here, and I'll say if the arc sine of root 7/4 equals t, then the sine of t is equal to root 7/4. And using SOHCAHTOA, you know that the sine of an angle is the ratio of the length opposite that angle to the hypotenuse. So one triangle I could draw would have this side length as root 7, and this is 4 here. And so I'm trying to figure out the cosine of t. Here's t. Cosine is just adjacent over hypotenuse. If I could figure out this value here, I'd be done. Well, to figure out that value, I'll give it a name, maybe a. I can use the Pythagorean Theorem. A squared plus b squared equals c squared. The sum of the squares of the lengths of the legs of a right triangle is equal to the square of the length of the hypotenuse. Or a squared plus b squared equals c squared. So a squared plus 7 equals 16. A squared is equal to 9. And so a is plus or minus 3. I'm going to take the positive solution here because I'm drawing this triangle here. Really, it's because I'm restricted to the first quadrant. But because in my triangle the lengths are all positive, it looks good. So now I got to figure out what's the cosine of t. Well, the cosine of t is adjacent over hypotenuse. So it's 3/4. And that right there is my answer. All right, this next one, the cosine of the arctangent of x. This will be very similar to the one I just did. I'm going to do another substitution. It's just here, instead of letting arc sine of root 7/4 equal t, I'm going to let arctangent of x equal t. And so really then what I'm trying to figure out is what is the cosine of t. Well, to figure that out, I'm going to have to draw a triangle. I'm going to draw a right triangle. I'm going to throw t down here arbitrarily. And I'm going to label my triangle using this statement. If the arctangent of x equals t, then the tangent of t must be equal to x. Instead of just writing it's equal to x, I'm going to write it's equal to x over 1 because it benefits me to have a ratio when I'm labeling the sides of my triangles. The tangent, using SOHCAHTOA, is opposite over adjacent. So the ratio of the length of the opposite side to the length of the adjacent side is x divided by 1. So I call this x and call this 1 and solve for this side length. So again, using the Pythagorean theorem, I got 1 squared plus x squared equals c squared. So c is equal to really plus or minus the square root of 1 plus x squared. But for the same reason as above, I'm going to take the positive solution and use this as my triangle. And now that I have my triangle labeled, I can figure out the cosine of t. Cosine of t is just adjacent over hypotenuse, so it's 1 divided by the square root of 1 plus x squared. And I'm going to call that my answer. I think I told you guys that you don't have to rationalize the denominator in this specific instance, but if you did rationalize the denominator, what you would come up with is it's the square root of 1 plus x squared divided by 1 plus x squared. So either of those are fine, but I'll leave this as my boxed answer because I think that's how I told you guys to leave it in class. Page 2, given a bunch of trig expressions and asked to simplify them. Okay. So in this first one, I got cosine of x times tangent of x divided by cotangent of x plus cosine of x. Well, there's a few things you could do here. To me, what I would probably do is recognize that there's a cosine in each of these terms. So maybe I'd factor out a cosine of x. And then what I would have left would be tangent of x divided by cotangent of x plus 1. And you can do these lots of different ways. This is just one way to do it. Tangent divided by cotangent. Well, tangent is sine over cosine. And cotangent is cosine over sine. So really, I'm dividing fractions, rational expressions if you're picky. And the way I do that is I change it into a multiplication problem by multiplying by the reciprocal of the denominator. So what that will give me when all the dust settles is sine of x times sine of x, aka sine squared x, divided by cosine of x times cosine of x, aka cosine squared x, plus 1. And I think what I would do with this step, again, you don't have to do this in this exact order, is I try to mash these all together, merge this into a single fraction. Well, one I could think of as cosine squared over cosine squared. So I got sine squared x plus cosine squared x, all divided by cosine squared x. And the advantage to this form is the Pythagorean identity tells me that sine squared x plus cosine squared x is just equal to 1. So I got cosine of x times 1 over cosine squared. This cosine and one of these cosines cancel out, and I get 1 over cosine of x or the secant of x. And either of these two answers are acceptable from my perspective. So I'll put the box around both of them and call that one good. What about this mess? Again, multiple ways you can solve it. I think the easiest way is to recognize that in this factor, both terms have a cotangent in them. And if you factor that out, you got 1 plus cosine of x. And in this term, in this factor, both terms have a secant of x in them. And if you factor that out, you'd be left with 1 minus cosine of x. So really what I have is cotangent of x times secant of x times 1 plus cosine of x times 1 minus cosine of x. And cotangent, as we saw above, is cosine of x over sine of x. Secant is 1 over cosine of x. It's going to simplify nicely. And then I got 1 plus cosine of x times 1 minus cosine of x. If I FOIL that out, I would be left with 1 minus cosine squared x. These cosines cancel, so I get 1 over sine of x times. And then over here, 1 minus cosine squared using the Pythagorean identity, that's equal to sine squared. And so I got sine squared x over sine of x, which reduces just to sine of x. And then this mess, I made this extra credit because it's pretty challenging. It's the same idea. You're trying to simplify a whole mess into one trig function. It's just this specific one. I think things get kind of ugly if I remember right. The first thing I would do is recognize that sine squared plus cosine squared just equals 1. So really I have 1 plus tangent of x divided by sine of x plus cosine of x plus cosine squared minus 1. Well, we saw up here 1 minus cosine squared was equal to sine squared. I don't have 1 minus cosine squared here. I have cosine squared minus 1. Turns out that that's equal to the negative of sine squared. So I can get something that looks like this. At this stage, it's probably most natural to find a common denominator, to multiply this side by sine of x plus cosine of x over sine of x plus cosine of x, and multiply this side by cosine of x over cosine of x. It turns out there's other ways you can do this problem. If you recognize, let's see, how would this work, that tangent is sine over cosine, then what I can do is get really clever here and say that sine of x is really just cosine of x times tangent of x. I don't really expect you to see that these two things are equal, but once you see it written, you can kind of verify it. Tangent is sine over cosine. So I got a cosine down on the bottom, but that cosine cancels with this cosine, so this thing right here is just sine of x. Okay, that was a weird thing to do. I mean, I guess I see why it's true. I wouldn't have seen that, but fine. I'll follow along. Well, the advantage to doing that is now you can factor out a cosine of x from each of these terms. And things are going to work out really nicely. In the numerator, I'll still have 1 plus tangent of x. In the denominator, I'll have cosine of x times 1 plus tangent of x. And then over here, I got minus sine squared x over cosine of x. And this 1 plus tangent of x and this 1 plus tangent of x cancel each other out. So I just get 1 over cosine of x minus sine squared x over cosine of x. And that's equal to 1 minus sine squared over cosine. That's because I got a common denominator here. But wait a minute, 1 minus sine squared, there's that Pythagorean identity again. That's equal to cosine squared x. So I get cosine squared x over cosine of x, which simplifies just down to cosine of x. You didn't have to do this little trick where you change sine into cosine times tangent. You could have changed everything into sines and cosines, and lots of different ways you can do this problem. I think this is the cleanest way to do it, the quickest way. And there's no way I can detail every way to do a problem, so I'll just kind of pick one and show you that. But if you get cosine of x as your answer, pretty good chance you did things right. All right, I'll call this good here.